Alright guys, so a quick lesson on solubility. I've got a flask here full of water, which of course we know is a polar solvent. And if you were to add something to that like, lactose. Okay, lactose is just a sugar. You can look up the structure for that. Lactose has a lot of alcohols on it, and so those polar groups, okay, you can see it down in there if I give this a little swirl. Okay, those polar groups make it highly soluble in polar solvents. Alternatively, if you put something that is far less polar, something like cellulose, okay, you can see that a lot of the cellulose is still sitting on top there, and we can make it a little more dramatic here. We'll just try and dump a little in. Making a mess, but that's all right. Cellulose is largely harmless. Okay, but you can see that it's not dissolving in the water, and that's because cellulose is non-polar. So polar things have a tendency to dissolve in polar solvents. That is, polar molecules have a tendency to dissolve in polar solvents. So things like sugar are going to dissolve very easily into water. Things that don't have polar groups on them, like cellulose, are going to have a harder time dissolving in water. At the same time, I asked you to look at the term miscible. So miscible usually refers to solvents that are mixable. So here we've got just some DI water, deionized water, and if we take something like isopropyl alcohol, right, we mix that in there. Okay. You'll see that those two mix perfectly well. There's no difference between them in terms of being able to see any separation. But if we take a non-polar solvent, something like cyclohexane, and we try to add that to our water, remembering that water is polar, okay, you can very clearly see a line there, right? So these are not miscible. You can't mix something that is polar with something non-polar. So you got the cyclohexane sitting there on top. Okay. Sometimes it's not enough to even have a polar group. So this bottle here, this is octyl alcohol, so that's 8 carbons. And it does have the alcohol. Alcohol we know is polar. But if we try to add a little bit of this to water, right? You see some bubbles there where they've kind of mixed, sort of, but they're going to fall out here. You can definitely see that layering effect, right? So polar things polar things like water are not going to mix with non-polar solvents, and sometimes it's not enough to have just one polar group. Okay, that octyl alcohol has only one alcohol group, and that alcohol group is polar, but it's got 8 carbons on it that are going to be non-polar. Okay, alternatively, if we take something non-polar, like cyclohexane, and try to mix it with something non-polar, or mostly non-polar, like the octyl alcohol, we'll see if these two mix. See, sort of, let's see. Okay. But you can certainly tell that those are mixing much, much better. You are seeing a few droplets in there. That's because I just dumped out a whole bunch of water. So those are probably just water droplets in there. But the two solvents themselves, the non-polar solvents, mix actually pretty well. So the idea here is that like goes with like. Okay, things that are polar are going to be miscible in one another. So we can mix small alcohols like isopropyl alcohol with water because they're both polar. Things that are non-polar are going to mix with solutions that are, or solvents that are non-polar.